And then this is going to be our amplitude. It could be down there or up here, either one. Okay. All right, so hopefully you notice that the cosine function is just a horizontal translation of our sine function. If we took this and we just scooched it over a little bit so that this maximum point was sitting right on the y-axis, then we would have the cosine function, right? So essentially they're gonna look the same. It's all about where they start. Do they start on the y-axis? Do they start at 0? Or do they start at another number? Okay. They are called sinusoid functions or sinusoidal. So sinusoid is the noun, and sinusoidal is your adjective. Adjective describes a noun. I say that like I know. Adverb describes a verb, right? Okay, whatever. Okay, I'll pretend that I don't know grammar. Yeah, it'll be okay. We'll get over it. All right, so other word functions that repeat at regular intervals are called periodic functions. Okay, so they just continue to sort of do the same thing over and over. Okay, so I double dog dare you to use the word sinusoidal in conversation at some point today outside of this classroom. That'll be awesome. Okay, just for sake of definition, the period is the length of one cycle of your sinusoidal function. Okay, that tells us how far that entire thing is going to happen. And what's going to happen as we graph different functions is, like, I know I'm recording, so I'm going to have to try to do this here. Okay, so look at my fingers. Like, this is 0 to 2 pi. Like, this is the entire function. So if this was the sine function, it would have to start here, it would have to go up, and then come back down, and come back to the middle in that space, right? If I take that space and I shorten it, this is now the period, 1 pi. The whole curve has to happen within this space, okay? Which means that between these two places, my sine curve is going to go up and come back down. So it's going to be like squished together. Does that make sense? Or if we widen that and we make it like a really long period of like 3 pi or 4 pi, right? We have a lot more space. So our curve is going to be like spread out like this, and it's going to be look wider, right? Like it's been stretched. Okay, so that's what the period is responsible for. Okay, how far do we have to get through that one cycle, right? Okay, amplitude is the height of one of our curves. Okay, it's going to go from the x-axis to the max or to the min, whichever one you want. It doesn't matter. I'm just going to put one of them, x-axis to our max. Okay. It is also half the distance between the highest point and the lowest point, right? So if you knew where your highest point and your lowest points were, you could just cut that in half and you would find that value, okay? So it could be found either way if you already have the graph drawn. Half distance from max to min. Okay. Okay, so that's all the instruction. Everything else is just examples, okay? So the first thing that we're going to do is we're going to look at some functions, and we're just going to tell what is the amplitude, what is the period. Okay, we're going to practice that first because we need to be good at that before we can start graphing them, okay? So you remember this a value that comes in front of our function? That's our vertical stretch, vertical compression. That's going to be called the amplitude, or that's going to determine how tall our function is, okay? So our amplitude is A. However, we need to make this the absolute value because our amplitude is always going to be a positive number. It's going to go up 5, or it's going to go down 5, but it's not, like, we don't worry about the negative. The negative just flips our graph upside down, right? Okay, so whatever that A value is, make it positive, that's our amplitude, okay? The period comes in here from our horizontal stretch or compression, that is the B value, okay? But in order to find that, remember the whole period lasts how far on the parent function? From 0 to, what value did we go to over here? 2 pi. So 2 pi is like the standard, right, on our parent function. So we're going to start with that 2 pi. And if there's a number in here where the B is in front of the X, then we're going to divide 2 pi by whatever that number is. And again, we're just going to make sure that that number is positive. We don't care about negatives at this point. Okay. All right, so on number 1, we're going to write the amplitude. I'm going to abbreviate it, amp, and we're going to write the period, PER. Okay, so the value for the amplitude comes from the A value, which is in front. So what number is in front of the word sine? What's in front of there? No number, so that's a 1. Okay. What about over here? Let's do this one. On number 2, what number's in front of the function? 7 over 2. So my amplitude is 7 halves. Now, when you go to graph that, it's kind of hard to graph 7 halves, so we change that to a decimal. 7 divided by 2 is 3.5. So then we would go up to 3.5. Yeah. Okay. Everybody okay? All right. So now for the period, we're going to take the other value, the B value, okay, which here is a 4. So we're going to start with 2 pi. Sine and cosine starts with 2 pi every single time. And we're going to divide that by whatever that B value was that we just had. Now I'm writing green on green. That might be stupid, but you can see that. Whatever. Okay. So this 4 is going to go down here underneath the 2 pi. And then we're just going to do a little bit of simplifying. 2 divided by 4 is the same as 1/2. So this would be 1 pi divided by 2 for our final answer. Okay, which means that if this is, from my fingers, is 0 to 2 pi, halfway would be 1 pi, and half of that again would be pi divided by 2. So that means in this little itty bitty space, we have to have that entire sine curve. So it starts at 0, goes up, comes back down, goes down to a bottom value, and comes back up, all within this space. Okay, so when you have a big number here, it's going to squish this together, right? That's our horizontal compression. All right, so on this one, what value is B for number 2? In front of the X? What number is there in front of the X? Why aren't you saying anything? Because there's nothing there? So what number's there if there's nothing there? It's just a 1. So 2 pi divided by 1 is just 2 pi. So that doesn't have any change. If there's no number there, your period will just be 2 pi. All right, so what's the difference on 3 and 4? We have a negative and the fraction. Okay, so the negative doesn't have anything to do with our amplitude and period. The negative is going to determine which direction our graph goes. So if this was my sine function, this is a positive sine function. So if there was a negative in front, instead of going up first, it's going to go down first, and then it's going to go up later. right? And if this was negative on my cosine function, instead of starting up here at a positive value, it's going to start down here at a negative value, and then it's going to go up and come back down, right? That's the only thing that the negative does in our equation. Okay, so if we were to try to find our amplitude, we're looking for the number in front of our function, and the number in front here is going to be just 5. Just the 5, not the negative. The negative determines which way our graph's going to be drawn. So this is always going to be the absolute value of negative 5, which gives us positive 5. Okay. All right. And then for our period, the regular period for the sine function or cosine function goes to what value? 2 pi. Say that, 2 pi. Okay. Then we're going to divide it by what value? 1/3. That's going to be awesome. So we're dividing 2 by 1/3. And you don't have a calculator? No, you don't. Put it down. You don't have a calculator. Okay? Because it's too easy. 2 divided by 1/3. Keep, change, flip. So dividing by a fraction is the same as multiplying by the reciprocal. So then we multiply this 2 by the top number, the numerator. 2 times 3 is 6. And then we're going to divide that by whatever is our denominator. In this case, it's just a 1. So this is just 6. Okay? But when we go back here, we had pi on this number, so we got to include that with our value as well. So 2 divided by 1/3 is going to give us 6 pi, which means our graph is going to be super stretched out, right? Like from 0 to 6 pi, we only get one cycle of that function. Okay. The other way you could think about it is if you have 2 pizzas or cookies or whatever, right? And you divide each of those into thirds, how many pieces in all will you have, right? That would give you 6 pieces. Okay, can you try number 4? And then we will move on to the actual graphing part. Right, set, go. All right, so what do you get for the amplitude? 2, positive 2. Anybody put negative 2? Change it to a positive if you need. Okay, always positive. All right, and then for our period, we're going to start with 2 pi, and we're going to divide it by 4/3. So 2 divided by 4/3 is the same as 2 times 3/4, which makes 3/2. Or if you don't simplify, you could simplify here. This 2 and this 4, you could divide both of those by 2 and make this a 2. And then we just have 3/2. Or you could do 2 times 3, which is 6, divided by 4. And then notice that that can simplify because both of those numbers can divide by 2. So we want a final answer of 3/2. So when we write that as our period, we got to make sure we go back and put pi with it. So we put pi with the numerator, typically. You could write it 3/2 and then the pi after it, sort of like you would with an x. But typically we put it with the numerator. Doesn't really matter. 3 pi over 2. All right, okay with that part? Okay, now the fun begins. Drawing pictures. Okay, and we are only going to look at the sine and cosine today. I was going to try to do tangent as well, but it was just too much to wrap our brain around. So we'll do tangent next time. Okay, so the directions say identify the amplitude and period, then graph the function. Okay, so things we need to look for. Okay, we need to look for a negative in front because that's going to change the direction that our graph goes, right? And then we also need to remember sine, cosine, because of the way direction our paper goes, or our graph goes. I want to go back and do one other thing that I forgot to do over here. Can we go back to this first picture, please? Sorry. Okay, the pattern for every sine function that is positive, right? The parent function starts here, and then it's going to go up to here, and then it's going to come back down and cross the x-axis, and then it's going to go down, and it's going to come back to here. Does that make sense? Okay? Yeah? So what we're going to do is we're going to call this is the middle of our graph. Do you see how it's like right at the center on the x-axis? So this is the middle, so it's going to start at the middle, and then if it's positive, it's going to go up to this value, which is called a max, right? But that's the highest point. We're going to call it an H because we don't want to use M again. We already used M for middle. So this is middle, high, and then the next point is going to be back in the middle, and then this point down here goes to a min, which is the lowest point, so that's a low, and then it's going to come back to the middle. Okay? So this is middle, high, middle, low, middle. Okay? Every sine function, every positive sine function follows that pattern. Okay? And that's what we're going to use to graph it on the next page. Okay? If it had a negative in front of it, it would still start with middle, but then it would go to the low, and then back to the middle, and back to the high. Okay? So that's the pattern we're going to follow. So what's the cosine going to do? The cosine starts, is this in the middle? Where is this point in relation to our curve? It's at the highest point. So it's going to start high, then it's going to cross the x-axis, which is a middle, and then it's going to go down here to a low point. It's going to come back to the middle, and then it's going to go up to a high value. Okay, so all of our graphs are going to start with these first 5 dots. Okay, we'll make one period of our cycle, and then we'll just repeat that. Okay. All right, so sine starts at the middle, cosine starts high, unless it's negative, right? Okay, so let's try number 5. All right, so first things first, we got to write our amplitude. So the amplitude for number 5 is 2. And do we have a number in front of the x that's going to change our period? Nope, so it's just going to be 2 pi divided by 1, which is just 2 pi. Okay, so again, this 2 tells us how high our graph is going to go. So the highest point on our graph is going to be a positive 2. The lowest point on our graph is going to be at a negative 2. And the rest of the graph is just going to zigzag between that. Okay? All right, so this is the sine function. Is it a positive sine function or a negative sine function? Is there a negative in front of the 2? Nope. So this is positive. So we're going to start in the middle, and then the sine function goes up from there to a high, and then it's going to come back to the middle, going to go to the low, and come back to the middle. Okay. I really need y'all to stay with me for a little bit, okay? All right, so here's the deal. This period determines this last middle. This, whatever this last letter is here, has to be at this value. So this is going to be 2 pi. And I'm just going to put it right over the top of those words. Okay? It's at 2 pi. the original starting place is at 0 or at my y, it's on the y-axis, right? So we're going from 0 to 2 pi along our x-axis. Everybody okay with that? Okay. Once you know what that value is, then you can start cutting it in half and cutting it in half again, right? So if this whole thing is 0 to 2 pi, then this m right here, which is in the middle of it, right? That's our middle dot, would be in the middle between 0 and 2 pi. So what's half of 2 pi? 1 pi. Okay? And then these dots that are in the middle there, what's halfway between 0 and 1? 1/2 or 0.5. Okay? So this is going to be half pi. And then 1 plus a half, right? In between 1 and 2 is 1.5 or 3/2 pi, right? 3 pi over 2 is the same as 1.5. Okay, so that tells us along our x-axis where our dots are going to go. Okay, then we decide how far up or down they go. For these functions that we're looking at today, we're not, look at my hands, we're not ever going to shift our function up or down. Okay, so everything is centered along the x-axis to start with. Okay, later I'll show you what happens when we start moving them up and down. Okay, so anytime you have a middle, we're just going to start, that middle is going to be on the x-axis. So those are just going to be zeros. Middles are always 0, unless you shift it up or down. Okay, middles are at 0. The other values, the only last two things we need is we need to know where our high is and where our low is. And that's determined by this amplitude. So if we go high, we're going to go positive, right? So that's going to be +2. And if we go to a low, that's going to be -2. Okay? And now I'm going to take these 5 values and we're going to put dots where those are, and then we can connect them, right? Okay, so the first one is at 0, 0. So we're going to put a dot there for our sine function. Okay, I want to graph the last one. Okay, so I'm going to go to the end. 2 pi is going to have a dot at 0 as well, right on the middle. Okay, now sometimes when we change our when we change the period to, like, it could be something weird. Like, do you know what half of 3/4 is? Like off the top of your head? No. Right? Or like, 1.5 pi. Like, I mean, we can figure it out. It's just a little more awkward. So sometimes we can just let the graph do the work for us. So look at my picture. Okay? These are the two ends of my graph. So there has to be a dot right in the middle. This middle has to be right in between them. So how many boxes between 0 and 2 pi? There are 8 boxes. So halfway would be 1, 2, 3, 4. Or you can just sort of eyeball it. Can you eyeball that that's the middle of those 2 dots? Yeah. Right? So using the graph will help a little bit, and we'll do that as we do some of the other problems. Okay, so now we're going to graph our high and our low. So at 1/2 pi, halfway in between these 2 dots, so it's going to be right here, right, on that line, we're going to go up to +2, which is right here. So we're going to put a dot right there. That's going to be our highest value. And halfway between these 2 last dots, which is going to be right here at 3/2 pi, we're going to go down to our lowest value of -2. Okay. And now we're going to connect the dots. This is your art lesson for the day. Okay, watch. These 3 dots make a mountain or a hill. So we're going to just do like a semicircle, right? Like a hill through those. And then these 3 dots down here make they're like a bowl or a valley. Okay, so I'm just going to do a little semicircle through those. I wouldn't try to do all of them at the same time because it gets to be sort of messy and ugly. Okay, so this is our sine curve. Okay? Now the only thing that we have to do is it keeps going, right? It repeats this pattern over and over. So we have to sort of finish it out. So I'm going to change colors here. So if I were to continue this line, look at, I'm tracing this line. If I were to continue this line from right here, which way would I go? Up. So I'm going to go up a little bit, and I'm going to put an arrow because we're at the end of our graph. I don't have to do anything more over there. Okay? But back on this side, I need to repeat my pattern. Okay? So I'm going to take this whole thing from right here, and I'm going to shift it back to here. Right? So what I do is I just reverse. Okay? If I keep tracing this, this is going to come down here, right? So this dot, instead of being up at a high, is now going to be a low, and it's every 2 boxes, right? 2 boxes over, we're going down 2. And then 2 more boxes over, and we're back at 0. Right? So this bottom part should match this bottom part. Okay? So if you were to trace it, you should just be able to continually trace up, down, up, down, up, down. Right? And then continuing back, now we need to go up. We're going to go up to here, and then back to the middle, and that'll give us that top bowl and with a little arrow on it. Does that make sense? Interestingly enough, that's the part that people have the most challenge with. I don't know. They just do. All right, let's try number 6. Number 6 says 5 cosine 1/2 x. All right, so our amplitude is going to be 5. Our period starts with 2 pi, and we're going to divide it by 1/2. So if you have 2 cookies and you break them into halves, how many new pieces do you have? You have 4 pieces, or you can do 2 times 2 over 1. So this is going to be 4 pi. Okay, now here's where it gets to be a little confusing, a little challenging, because our graph only goes to 2 pi, right? So what this tells me here is that this whole curve has to go from 0 to 4 pi, which is like way out here off my paper, right? So the cosine curve is going to go in between these 2 points. So remember, the cosine starts high, it's going to come down, and it's going to go down like this, way over here. So we're only going to see part of that because our graph only goes to 2 pi, right? Okay, so we'll deal with that in just a second. All right, so the cosine curve, is this a positive cosine or a negative? This is positive, so the cosine curve starts where when it's positive? It's going to start high, middle, low, middle, high. High, middle, low, middle, high. Okay? So the middles are going to be at what number? Middles are at 0. Middles are at 0. The highs are going to be at positive 5. Highs are at 5. And the low is going to be at same number, but negative. Negative 5. Okay, so we got that part. Now we just have to figure out where those go, right? Okay, so this is our y-axis. The very first dot is our y-axis. So we're going to have a dot on the y-axis at positive 5. So that's going to be way up here. Okay. The last dot is at the end of this period, which is 4 pi. So I can't draw that because it's not on our graph, right? So now we need to find the middle in between these 5 points. So in the middle of all these points, we're going to have a low at -5, halfway between 0 and 4 pi. What's half of 4 pi? 2 pi. So at 2 pi, we're going to have a dot at -5. So we're going to go over here to 2 pi, and we're going to go down to -5. Okay, now this is going to be our curve, right? This top part is the mountain, and the bottom part is the valley. Okay, so what's halfway in between these two dots? I'm going to bring these dots to the x-axis. I have one dot at 0 and one dot at 2 pi. Halfway in between them is pi, right? Right here in the middle. And that's on the middle, so that's going to be at 0. At 1 pi, we're going to have a dot right there. And that's all we get, right? So this is my curve coming down. Change directions. This is the bowl, so this is going to come back up on the other side, on the right. And then we just need to finish it out over here. So we're just going to do a reflection, right? We're going to do the same thing, but on the other side. So we had a dot at 1 pi, so we're going to have another dot at -pi. So the rest of this curve, the rest of this mountain can come down to that. And then we had a dot at 2 pi, so we're going to have a dot way down here at -2 pi for the bottom part of this. Okay, and this is why pencil is helpful, because sometimes those dots get all sorts of in the wrong place. Okay, because you're going through this. Okay, pencil first. All right, let's do number 8. So what's different about number 8? It has a negative. So this negative value right here is going to make our graph go the other direction, right? Okay, so what is our amplitude? There's no number with that negative, so that's just going to be a 1. So it's only going to go up to 1 and down to -1. So it's not going to be very tall. And then our period is going to be 2 pi divided by 8/3. So 2 divided by 8/3 is the same as 2 times 3/8. So 2 and 8 can simplify, so that's going to be 3/4. So 3 pi over 4. Okay, so our graphs are already set up so that you have 4 boxes between 0 and pi, right? So just like on a ruler, right? So this is, actually I'm going to write it down here because we're not going to do this problem. This is 0. This is half, right? So this line right here is pi divided by 2 because it's halfway between 1 pi and 0. And then these other lines are going to be your fourths. So this first one is pi over 4. Okay, watch how I count. Look at my paper. Watch how I count. 0, 1/4, 2/4, which is the same as 1/2, right? The next line is 3/4. Just put on a pi. The next line is 4/4. 4 divided by 4 is 1. So this just becomes 1 pi. The next line after 4/4 becomes 5/4. 6/4, 7/4, 8/4, right? All of your graphs for this are going to be in fourths like that. Okay, so that should help as you're drawing your graph. Okay, so our period is 3 pi over 4. All right, so the sine curve, does it start high or in the middle? Sine starts in the middle, so just keep looking back at that if you need to. Okay, so does this one go middle up or middle down? Because of this negative, we're going to go down. So this is going to go middle low, middle high, back to middle. Oh, sorry. Yeah, the negative makes it go down first. Okay, so let's put in our numbers across the bottom. The numbers for this, middle is at what number? Every time. Middle is on the x-axis at 0. Okay, because we're not shifting it up or down. Middle is always 0. So all of these m's are 0. And our low and high go off of this amplitude. So low is going to be -1, high is going to be +1. Okay, so that tells us how high up and down our dots are going to go. Those are going to be our y values. Okay, then we have our x values on top. So we're going to start here at the y-axis. And then our very last dot has to go at what value for this particular function? This thing, 3/4 pi, which is itty bitty, right? Compared to what we were doing before. So it's going to be squished together, and we're going to have our whole sine curve inside that smaller value. Okay, so does anybody know what 1/2 of 3/4 is off the top of their head? No. Okay, so I'm not going to fill in the rest of this stuff. I'm going to use the graph. Okay, so I'm going to use the graph for these middle dots, okay, because I'm just going to like count boxes and then cut the boxes in half, right? It doesn't have to be perfect. It'll be an estimate. Okay, but I know that the y-axis is going to have a dot at 0. We know that for sure. And we know at 3/4 pi, we're going to have a dot at 0. So 3/4 pi is how many lines over? 3. 1, 2, 3. Dot at the middle, 0. Okay, so here's the deal. In between these two dots has to be our entire sine function. Is it going to go up, down, up? Is it going to go up first or down first? This one is it's negative, so it's going to go down. So I'm just using my pencil. I just want you to see what it's going to look like. Okay, it's going to look something like this, right? It has to go down, come back to the middle, and then come back up, right? The whole thing in there. But we need the exact values for that. Does that make sense? Okay, so this middle point where it's going to cross back across the x-axis is just halfway between those two dots. So that was 3 boxes. So halfway between 3 boxes is right there. 1.5. Okay, and then I'm going to do halfway in between those 2 boxes. Half of 1.5, or half of, that's not right. Yeah, half of 1.5 is like 75 cents, right? Half of $1.50, 0.75. So it's sort of like right here. And then the first one, we're going to go to a low. We're going to go down to -1. So not right on the line for 1, but just a little bit to the side. Okay, so we're going to come way down to here, right in the middle between those 2 dots. And then right in the middle between these 2 dots is maybe like right about there. And we'll go up to our high value of 1. Okay, so got to have those 5 dots. And then we're going to make a bowl on the bottom and a little mountain on the top. Okay? Now, this is a super tiny curve, which means it's going to repeat a whole bunch across my graph, right? Okay, so watch. Every 1.5, I had a dot, right? 1.5, 1.5, 1.5, 1.5, right? Those dots along the middle, okay? Every 1.5, I put a dot, okay? I'm just going to do this side for right now. And then between the first two dots, we had a low point down here at 1, not quite on the line. And then between the next two dots, halfway between those, we had a dot up at the top. And then between the next two dots, we had one down at the bottom. And between the next two, we had one that goes up. Okay? And when you look at the dots that I drew, they look like this, right? But we don't want to connect them like that. We want to connect them with the curve. Okay? So make sure that you're curving your valleys and mountains, or whatever you want to call them. Okay. And then you could draw the rest over here. Like if this was your assignment or this was a test or quiz or something, like you would need to draw that all the way across the paper. Okay, I'm not going to do it right now. All right, last one. Let's do number 9. All right, number 9. Can you please find the amplitude and the period? Ready, set, go. So 2 divided by 2/3 is the same as 2 times 3/2. So those 2's are going to cancel out, and we're just going to be left with 3 pi. Amplitude of 5/2. What?
Does the 5/2 have to be 5/2?
What would you prefer to write it as?
2.5.
Sure. Yep. All right, so this is a cosine function. So the cosine function starts high. So does this one start high or low? Is this reflected? This one has a negative in front. So instead of starting high, this is going to start low and go low, middle, high, middle, back to low. All right, so the next step, can you write the numbers underneath this? What are our y values going to be for these lows, middles, and highs? Which ones are at 0? Which ones are at 2.5? Put that underneath. So we should have the middles at 0. Lows are going to be negative 2.5. And our high is positive 2.5. Okay. All right, now up on top of this, write in which one's going to be at the y-axis. Which which is our starting point. That should be this first one, should be at the y-axis. And then the last point, write in where that should be. Where should our last point be? This changes depending on what our period. So this is going to be our 3 pi. All right, so half of 3 pi, half of 3, 1.5. So this middle is going to be at 1.5. Do you want to do half of 1.5? Or do you want to just eyeball it on our graph? Let's eyeball it. Okay, so we're going to start graphing our points. So let's graph the first one. We're going to be on the y-axis, and we're going to go to negative 2.5. And then our last point is at 3 pi, which goes off of our graph, right? So we're not actually going to see this point on our graph. So let's go to the middle next. Okay, so again, the order is the two ends, left and right, and then the middle point in between those, and then the middle of each of those, right? So this middle point is at 1.5 pi. So halfway between 1 pi and 2 pi is going to be right here at this second line. And at this point, we're going to go where? 1.5 goes up to 2.5. So it's going to be our high point. And then we need our middle. So where does this, if I were to draw a curve in between here, halfway in between these 2 points, my curve is going to cross the x-axis. So can you find where that dot would be? If you need to count the number of boxes, this is 6 boxes. So halfway is going to be at 3 boxes over, or at 3/4 pi. Okay, so here's what this tells me, okay? I'm going to have a dot every 3 boxes, right? Every 3 boxes, we're going to put a dot, whether it's high, middle, low, middle, high, like we're just going to follow that pattern, right? So this is low, 3 boxes later, middle, 3 boxes later, high, 3 boxes later, we should have middle again. Okay, so going the other direction, going back this way, we were at a low. So if I go back this way 3 more boxes, where do I want to be? Do I want to be at a high, a middle, or a low? If this one is low, we need to go back to middle, right here, low, back to middle. Then the next one is high, so 3 boxes back, we're going to go up to a high, and then 3 more boxes will be at middle. Okay, and if you ever have like 2 dots that are like both at a low value, or like low, middle, low, like your graph is just going to look weird to you. Like it needs to have this up down pattern that looks sort of normal. Okay. Okay. All right, so this is the practice for today. Again, I really would like for you to use pencil while you're doing this so you can erase. I can't tell you how many people were writing in pen yesterday and they're like, Miss, can I get a new paper? Love them, but still. Okay, so this is going to be assignment 20, okay? And we're going to do for today, okay? Today we're going to look at problems 1 through 8. Okay, 1 through 8. And then next time we'll do the tangent graph and we'll finish the rest of the problems. So there's 9 through whatever, I think it's 12. So don't like cross them all out and